Hey everyone, welcome back to the channel. This is Rahul. Today we are solving another interesting problem from lead code. It is a tree problem and that is most profitable path in a tree. In this video we will cover problem explanation with one example, different ways to solve the problem and why DFS is the best choice. Then we will write one efficient code so that even beginners will also understand, and we will explain the time and space complexity and its efficiency, and we will explain why this one is efficient among others. If you enjoy DSA tutorials, don't forget to like, subscribe and share. So this is our problem. So I will just give you the brief about this problem rather than going each thing. So here we are given one indicator tree with n nodes, and each node has a gate with a cost. It will make negative values, and reward it will be positive values. So we have two people, Alice and Bob. Alice starts at node 0 and moves towards a leaf node. Same time, Bob starts at node Bob and move towards node 0. In the input, we have one value that is taken as part of which from which node Bob has to start. That's why I'm just mentioned from that node to node 0. If they reach the same node at the same time, they split the amount. Like that, we have to do. So just go through this example. So here the output is 6 as per the last one. So okay, here I don't know whether you can see or not. Okay, so 0, 1, 1, 2, 1, 3, 3, 4. That's the path given. Here Bob equal to 3. So Bob will start from node 3. Okay, so here they open the gates of their respective nodes, and Alice is at initially at node 0, and Alice wants the most profitable path to a leaf. Same time Bob moves towards 0 step by step, and the split means once they meet, if Alice here and Bob is in third node, then once they move they will reach here. Okay, so minus 2 plus 4 by 2, that's it mentioning here the value is minus 2, and they will divide the values. So that's the way they are splitting the reward, that's it mentioning. So in that way we have to write the problem. So in this one we have actually three approaches we could use. So first of all is the normal one, that is the brute force. Means we will do depth first search on all path, which will lead to exponential complexity. I will just explain why. First of all, it will try all possible paths that Alice can take using DFS. Then, as you know, for each path, track Bob's movement and compute the profit. But it will lead to big of 2 raised to n. It will be a too slow for last tree process, but the thing is, if it greater than 20, if the value of n greater than 20, it will leads to exponential growth. Second one is dynamic programming on trees. Here we are tracking max profit with memorization, which means first of all we store the maximum profit possible from each node using dynamic programming. Then it will become complex because Bob's movement affects Alice's earnings dynamically. So it will be difficult to implement, and for some cases it become inefficient. So for these reasons we are using depth first search with the Bob path tracking, which is optimal. So thing is it will take only big of n time. I will explain later why. So here first of all we have to convert the input into an adjacency list. Means in a tree structure, then we have to track Bob's path and record when he reaches each node. Later we have DFS from node 0 finding the best path for Alice. At each node we have to check if Bob hasn't reached, then Alice gets the full amount. If Bob arrive at the same time, then we have to split the amount. If Alice reaches a leaf node, then the profit is finalized. So that's the thing we have to do. So as it processes each node once, we get a time complexity of big of n, which make it efficient. So this is the best approach because it efficiently considers Bob's movement while optimizing Alice's path. So let's start our coding. Here you can see our input edges and one value for Bob and amount. First of all, we have to create adjacency list to represent the tree. So we will use array list. We will name it as graph new array list length. Now we have to initialize adjacency list for each node. For that we will use one for loop int I is equal to 0, I less than graph dot line, I plus plus. Then we have to initialize the value for for graph of I is equal to array list. So once this done, we have to populate the adjacency list, which should be in bidirectional. Means we have to adjust so A to B and B to A that way. For int edge in edges graph 0 add edge of 1. Same like we have to do for next graph edge of 1 add edge of 0. Once this done, come out of the loop. Now we have to find Bob's path to node. For that, we have to create one array to store when Bob reaches each node. So int, we will name it as Bob path new int of amount dot length. Okay. Now we have to initialize to -1 means if Bob hasn't reached yet. Arrays dot fill Bob path -1. Now we have to create one list to store Bob's path from Bob to 0. So we will use array list integer. We will give one name as path array list. Now we have to populate Bob's path using DFS. For that we will use one helper function fill Bob path Bob -1 path graph. So here this one is the node and this is the parent node. Then this is our list and this is the list we already created um, as the tree structure. Okay, so once that's done, we have to assign each node the timestamp when Bob reaches it. For enter is equal to 0, size, then increment I. Bob path path no, get of I is equal to I, and same time we have to return we have to process Alice DFS with profit calculation. For that also we are using one helper function return get Alice max score 0 uh, -1 0 both path graph 0 amount. Here what we used are first of all the node, then parent node, then current score, then the Bob path which is the array, and the tree structure and timestamp as well as the amount. So once that's done, come out of the method. Now we have to start with our helper method to track Bob's path. So private boolean fill Bob path int node int parent node array list, integer path, then graph. Okay, so once this done, we have to check the base condition. Means if Bob already reached node 0, then we have to return true. So if node is 0, then nothing, return true. Now we have to start the depth for search through the tree to find Bob's path. For int neighbor node graph node. Okay. If neighbor node is not equal to parent node, then we have to add current node to the path. If parent node path node add node. Now we have to um, call the helper method here again. If fill Bob path neighbor node path graph. Okay, then nothing. We have to return true. So if we found this, nothing else to do, or else we have to um, backtrack if no valid path found. So path remove size of -1. Come out of the loop and return false. Now we have to go for the next helper method, that is add is max score, to get add is maximum score private int get add is max score. We have to give some inputs: node, parent node, then current score, bow path, then graph, that is the tree thing, integer, graph, then timestamp, then amount that she getting. Okay, so first of all we have to determine Addis earnings based on Bob's presence. So if Bob path is equal to -1 or Bob path greater than timestamp, then Harris will get full amount. Current score plus equals amount node. Okay, if they meet together means if they collide, then they have to share the reward. Else if Bob path node equal to timestamp, then current score plus sorry plus equals node divided by 2. Okay, now we have to check whether Alice reaches a leaf node. Then we have to return the current profit. If tab of node dot size is 1 and not equal to 0, return current score. Same time we have to create one variable to track maximum profit. Int max score is equal to, so as of now we will give the least value for this max score. We will use the min value integer dot min value. So once this done, we have to traverse all child nodes using DFS. For neighbor node, of node. Same like before, if neighbor node not equal to parent node, we have to get the max score. We have to update it. That's the thing. neighbor node not equal to parent node. Then update max score math dot max of max score get alice max score neighbor node current score both path graph timestamp plus 1 and amount. Once this done, we have to return the max score. Let's run it. Yeah, spelling mistakes. What's the next one? 1020. What's it in? Okay, let's try. Okay, we forgot to give node. That's why. See, it's working fine. So here the complexity analysis. So for time complexity, we have graph construction which took big of n and tracking Bob's path same big of n. Then Alice depth first search same big of n. So the overall complexity is big of n only, which make it efficient for larger trees with up to 10 raised to 5 nodes. So when it comes to space complexity, the graph storage took big of n, Bob's path storage big of n, and the DFS recursion also big of n in the worst case, and memory efficient since we only use extra array of size n. That's it. Let's submit it. Mm, where is it? Line 22. Okay. Staff node. Mm, overflow. Let's see what's the issue. We have the graph. Okay. Return true. Neighbor node. Graph node. Okay. Current path. Force. Mm, what's the issue here? What path? According to my mm, both respawn path graph symmetrical pattern. What we are missing here? Something here, I think. Okay, so the issue here is you have to keep this inside the if loop only. That's it. Sorry for the confusion. Yeah, it's working fine. So that's it. If you found this helpful, don't forget to like, share, and subscribe. And if you have any comments or feedback, just comment it below. See you in next one. Till that, happy coding.